Hello, today we'll understand how to predict the formation of the products or a no reaction case in a double displacement reaction. So, a double displacement reaction only takes place if the products formed, one of them, either it is a solid, a liquid, or a gas. So we'll take the first example where one of the product formed is a solid. So in this reaction, sodium sulfate, which is aqueous, and lead nitrate, which is again aqueous, these are reacting together. So in a double displacement reaction, there is an exchange of ions. So the sodium will go with nitrate and the lead will go with sulfate. From our solubility chart, we can see that sodium nitrate is soluble in water, but lead sulfate is insoluble in water, which means when we are writing the products, we can write PbSO4 is a solid and sodium nitrate NaNO3 is aqueous, and because now we have formed one of the products which is a solid, so these are the correct products of this double displacement reaction. And now we are just going to balance out this chemical reaction. So Na on the left is 2 and Na on the right also, we'll make it 2. Nitrates also become 2 and nitrate over here also is 2. So this is the first case of a double displacement reaction. The second one is where there's a formation of a liquid, and those specifically are neutralization reactions. So we'll take an acid H2SO4 and make it react with a base which is NaOH. Here H2SO4 is aqueous, NaOH is aqueous, and once they react together, again Na goes with sulfate, so we'll form sodium sulfate, which is aqueous because this salt is soluble in water, and the other product will be H going with OH, which is H2O, and this is a liquid. And because we have formed one of the products as liquid, so this is the double displacement reaction where one of the products formed is a liquid. Now we'll just balance it out. Sodiums on the right are 2 and we'll make sodium 2 over here also. Hydrogens total are 2 over here and 2 over here. So we have 4. We'll make 4 hydrogens here. So this is a complete balanced chemical equation. Now we'll take a third scenario where the formation of a gas takes place. So here we have sodium carbonate, which is aqueous, reacting with HCl, hydrochloric acid, again aqueous. When these two react together, the sodium will go with chlorine, so which forms sodium chloride, soluble in water, aqueous. For the formation of the other product, H will go with carbonate. So this forms carbonic acid, which is H2CO3. But this H2CO3 immediately breaks down into water and carbon dioxide. So we are going to replace this H2CO3 by H2O and CO2. H2O is a liquid, CO2 is a gas. So here again we have two products, one being liquid, the other being gas. So this is another type of a double displacement reaction where one of the products formed is a gas. Now to balance it out, we have 2 sodiums over here. So we'll make sodiums 2. Chlorines are 1, but chlorine 2 over here. So we'll put a 2 here. And this is our balanced chemical equation. Now we'll take a case where there is no product formed. Now if I take KCl, which is aqueous, and make it react with NaNO3, which is again aqueous, so we know that it's going to be the exchange of ions. So potassium will go with nitrate and sodium will go with chloride. Now if you see the solubility chart, potassium nitrate is soluble in water and sodium chloride is also soluble in water. So both the products are aqueous. So in this case, it is going to be a no reaction, and the reason being, if you write a net ionic equation for this reaction, all the spectator ions are going to get cancelled out and you will have nothing in the net ionic equation. So if you don't know how to write the net ionic equation, you can check out the video and you'll understand why this is a no reaction. But in summary, if you are getting both the products as aqueous, it means you please don't write them down, just say no reaction. I hope you understood the concept. See you in the next one. Bye bye.